Hi everyone, the channel Easy Lecture welcomes you. So in this series we are discussing about the applications of operational amplifier. So in this video we are going to discuss one of the applications, that how operational amplifier can be used as clipper. Before entering into the video, subscribe my channel Easy Lecture. Now we shall go for further discussion. Okay. What is meant by a clipper? So clipper is a circuit that eliminates some portion of the input signal and produces the output. Okay. So basically it is a wave shaping circuit. So there are other types of various wave shaping circuits such as clampper, sample and hold circuit. So we shall discuss them one by one. So in this video we shall talk about a clipper. Okay. So here, if a signal is given to a clipper circuit, then the output of the circuit gives a waveform in which the portion of the input waveform above a reference voltage or below a reference voltage is completely eliminated. Okay, so other portions of the input waveform remains the same in the output waveform. Okay, so this is what a clipper does. So according to this, clipper can be classified into two types. One is positive clipper, another one is negative clipper. In positive clipper, the portion of the input waveform above the reference voltage is clipped, is eliminated, is clipped off. So that is positive clipper. Whereas in negative clipper, the portion of the waveform below that reference voltage is completely eliminated. Okay, so from where does this clipper arrive? Okay, so as I mentioned, apart from the clipping portions of the signal, the remaining portions remain same. There won't be any change. Okay, so basically it should be a voltage follower circuit because the remaining portions are same. So the output voltage is same as that of the input voltage. The output signal is same as that of the input signal for the remaining portions. So basically it should be a voltage follower circuit, right? And to this voltage follower circuit we have to make certain changes, and according to the changes that we make in the design, the clipping operations are done. Okay, so what is the main ingredient, main device that performs this change is nothing but it is PN junction diode. Okay. Let us see what happens with respect to compared to the operations of voltage follower. So here this is the voltage follower circuit, and in this voltage follower circuit, what happens? We are giving the input signal to the non-inverting terminal, and to the inverting terminal there is a feedback loop from the output signal, right? So this circuit acts as a voltage follower. The output voltage follows the input voltage. So whatever the signal that we provide in the input, the same signal appears in the output, right? So this is voltage follower. Now what happens if we connect a diode here? The output, if we connect a diode here, what happens? So this circuit will perform a rectifying operation. Okay, so we know what is in the rectifier. What is in the rectifier? Okay, so a rectifier is a circuit that is used to convert an alternate current into direct current, AC into DC. Okay, so using diode it is converted into pulsating DC, and after that voltage regulator by further operation. That is by using voltage regulator, the pulsating DC is converted into pure DC. So this is how this is what we do in converting an AC into DC, right? Now this diode, when we look into the operation of diode, it is basically a switching device. Yes, it is basically a switching device. So when it is forward biased, it acts as a switch and the switch is closed, and when it is reverse biased, the switch becomes open. It does not conduct. Okay, so that is the working of diode. So what happens, since this is voltage follower and in the input side we are giving a sinusoidal waveform. So sinusoidal waveform means it can be either a sine waveform or cosine waveform. Okay, so here we are giving a sine waveform. Okay, and this sine waveform has a positive cycle and negative cycle. Okay, so one complete cycle of an input signal has a positive half cycle and negative half cycle, and this is called as zero amplitude level. Okay, 50% of the signal is above the zero amplitude level, and the remaining 50% is below the zero amplitude level. Okay, so this is the thing. What happens? In this voltage follower, the same input signal appears in the output, but when it passes through this diode, for the positive half, if the diode is connected in this direction, for the positive half, the diode becomes forward biased and the switch closes, and we will be getting the positive signal. Okay, whereas when the input signal reaching the operational amplifier is negative cycle, at that time the diode is reverse biased and it is open, it does not conduct any current. As a result, there is no output voltage for the positive cycle, for the negative cycle. Okay, so in this manner, connecting a diode to the output of a voltage follower performs a rectifying operation. Right? Okay. Now what happens if we connect the diode in the reverse direction? The same thing happens, but the thing is, for positive cycle, the diode is reverse biased and the switch is open. Okay, and for negative cycle, the diode is forward biased and the switch is closed, and it produces the output in the positive region. Again, in the positive region. Okay, so whatever the input signal be, the output is produced in the positive region only. Okay, but for our requirement, we are producing a clipping circuit, a clipper circuit. For that, some portion of the negative region or some portion of the positive region should be eliminated, not entirely, and it should not be biased to the single direction. Okay, so this is the thing. So where should we connect this diode to perform that, to do that operation? So that is an important thing. Let us see. So instead of connecting diode after the feedback loop, we have to connect the diode before the feedback loop, within the feedback loop. Okay, let us see. Okay, so this is how the connection should be made. Okay, again, this circuit performs the rectifying operation. Okay, half wave rectifier. It performs the operation of half wave rectifier. Right? So here, when the input signal, when the input signal is in positive cycle, the diode is forward biased and produces the output. Okay, in the positive direction. Right? And for negative cycle, the diode is reverse biased and it does not produce any output, and the switch is open. Okay, so this is the thing. Now for negative cycle, so this is the thing that happens for negative cycle. Now let us see if what happens if the diode is connected in a reverse direction. Okay, so the diode is connected in reverse direction. So instead of in this direction, we are connecting the diode in this direction, right? Correct. So in this condition, for positive cycle, the diode is reverse biased and the switch is open, so it does not conduct. For negative cycle, the diode is forward biased now and the switch is closed. Now it conducts, and in the output it produces the signal in the negative region, same as that of the input. Okay, So this portion appears in the output as it is. Okay, so this is the main idea behind it, because we are connecting the diode within the feedback loop and it is feedback here, right? So this is the reason why we are connecting the diode within the feedback loop. Now with this idea, we need to perform clipping operation. So how to control the reference voltage, how to control, how to eliminate this signal, the portion of signal above that particular reference voltage or below that particular reference voltage. How do we do that? Okay, so for that we are going to make use of the supply voltage. Okay, so here operational amplifier to operational amplifier we are giving two power supplies. One is to the 4th pin and another one is to the 7th pin. Okay, and we are using the power supply that is given to 7 pin. So this is the this waveform shows the half wave rectifier, operation of a half wave rectifier. For positive cycle the diode is closed and it conducts. For negative cycle the diode is open and it does not conduct. It is reverse biased and it does not conduct. Okay. Alright, so here as I mentioned already, the operational amplifier has two supply voltages. One is to the 4th pin and another one is to the 7th pin, and we are taking the reference voltage from 7th pin. So here we are taking the reference voltage from this 7th pin, and this is the controlling knob required to vary this reference voltage. This reference voltage can be varied using this portion of the circuit, and we are making the connection to the feedback loop like this through that resistor. So what happens, as I mentioned already, this is basically a voltage follow circuit. So whatever the voltage that we are giving in the input side, that appears in the output side. But here, since the reference voltage is there and the diode is connected in this direction, the N-type semiconductor is connected to the output of the N-type semiconductor is connected to 6th pin of operational amplifier. So what happens, this form of circuit clips the positive portion above the reference voltage. Okay, so here when the input voltage, so input is a sinusoidal waveform and this reference voltage, it is a continuous amplitude level of DC amplitude level. Okay, so it will be like this, right? So if the input voltage is less than the reference voltage, okay, now again I will make it more clear. So this is the sinusoidal signal which has to be clipped, and this is the reference voltage, and this is 0 amplitude level. Once again, let me make this portion within the frame. Okay, so this is the input signal, and let this be the reference voltage, and this is 0 amplitude level, right? This is reference voltage. And this is 0 amplitude level. So what happens? The input signal, when the input signal, so this is the input signal, when the input signal is less than the reference voltage, the output signal that comes out of the 6th pin of operational amplifier makes the diode forward biased and it conducts. So the portion of the signal below the reference voltage appears in the output like this. It appears in the output, right? So this one appears. Whereas when the input voltage, when this input voltage is greater than the reference voltage, the output signal that is coming out of the sixth pin of operational amplifier make the diode reverse biased. So for the positive portion, there is no output produced. So this portion is eliminated. Okay, so this is how the circuit perform the operation of a positive clipper. Let us look at the waveform. So the voltage above the reference voltage is eliminated, and the portion of the signal below the reference voltage appears as it is in the output signal. Right? So this is the thing. Now, how to perform the negative clipping operation means just we have to change the direction of PN junction diode, which is connected to the sixth pin of operational amplifier. Okay, so in this circuit, what happens if the input signal, okay, so here this is the input signal, and here we are giving the reference voltage. Okay, so it is a DC level, DC amplitude level. Okay, right? So let us assume that the DC amplitude level be here, and this is zero amplitude level. Okay, so this is zero amplitude level, this is reference voltage V or E F, right? So this is reference voltage. Now what happens, the input signal that we are giving here, if the input voltage is greater than the reference voltage, then in this voltage follower circuit, the output signal appearing from the sixth pin of operation amplifier make the diode forward bias and it conducts. So the reference voltage, the portion of the signal above the reference voltage appears in the output. Okay, and if the input signal that is given in the non-inverting terminal of operational amplifier is less than the reference voltage, then it makes the diode reverse biased and it does not conduct. So here what happens, the portion of the signal below the reference voltage does not appear in the output. So this circuit makes the negative clipper, right? This is the waveform of a negative clipper circuit. So the portion of the signal below the reference voltage, here we are giving the reference voltage at this point, right? And the portion of the signal above the reference voltage, the diode is forward biased, and for the portion of the signal below the reference voltage, the diode is reverse biased, and there is no signal appearing for that portion in the output, right? So this is negative clipping operation. So I hope you understand from this video what is meant by a clipper and how a clipper is transformed from voltage follower circuit, and what are the types of clipper, how to perform the operation of positive clipper, negative clipper using the operational amplifier, and employing an active device such as PN junction diode. So all these things you might have understood from this video very clearly. Thanks for watching this video. Don't forget to make comment, like and share, and don't forget to subscribe my channel Easy Lecture. So we shall meet in another video. Until then, bye. Thank you.